Hello viewers, welcome to Quick Coder. My name is Tulsi. Today's topic is how to delete a node at first, middle, and at last in the linked list. So in Java. So once you done it once you understand the concept, you can do it in any language. Okay, so let's get started. Okay, so let's continue. Here deleting a node at first. So this is the linked list I have that is pointing to the first node. Okay, so here I have totally three conditions. The first condition is if there is no linked list, presently there is no linked list, and my head is still pointing to null, then what I should do? I should do what is that? If my head is equal to null, means there is no node yet, then I should print no node to delete. Okay, this is the first thing you have to understand. And what is the second rule? What is the second rule is if my means if I have only one node with me, then it will point to null node and it will be head. If I had only one node, this is the node I want to delete. This is the first node. Now, what is the second rule is if my head dot next means I have only one node. If my head dot next is equal to null, then what I have to do is I should make my head as null. Okay, again I have to make my head as null. So that's it. If I delete this, there is no node here and my head again points to null. That's it. And what is the third rule? So right here third rule. What is the third one is, okay, I have more than one node in my linked list. Then simply my head is equal to head dot next. What will happen here is, here my head will is equal to head dot next. What is head dot next? This. So this will be head here. There is no node now. This will be my starting node. That's it. That's all the three cases. First of all, if you have no node, then you have to print no node to delete. If you have only one node, you make it as head is equal to none, because that is the only node you have to delete. You should make head as none. Otherwise, if you have more than one node, then you should make head is equal to head dot next. That's it. That's it about this deleting node at first. Now let us understand how to delete node at middle. So let's start how to delete a node at middle. I already explained how to get the middle element is, or you can use the fast and slow pointers. Okay, so that you will get the middle element. But you have two cases. That cases are I already explained while deleting a node at first. So what is the first one is if my there is no node. Okay, again the same thing. If my head is equal to null, if my head is equal to null, then no node to delete. No node to delete. Otherwise, what is the second one? If I have only one node, means head dot next is equal to null. If I have only one node, that is the node in the middle. So again, head is equal to head dot next. Okay, so that's it. And or I can also say head dot next is nothing but null. No? So I can also say head is equal to null. And again, else. What is else here? Now I have to find out the slow pointer and fast pointer. Always my slow pointer will be here and my fast pointer will be here. My fast up to my fast is not equal to null and my fast dot next is not equal to null, so that I can continue the steps. Means slow pointer will move only one step and fast pointer will move two steps. No? So first of all, my slow pointer will be moved here and my fast pointer will be moved two steps, means my fast will come here, and again I will note down the previous slow. Okay, I will maintain the previous slow also. Okay, my previous slow is here, my previous to slow. Then again my fast dot next is not equal to null and fast is not equal to null, so I will jump this slow here and my fast will be here and my previous will be here. Previous will be here. So my slow came to here, my fast goes here, and I should maintain the previous one. So previous one, what I want to do, this is the middle one, no? Where is my slow? That is the middle one. So I want to delete this slow. Where my slow is pointing, I want to delete that. So how to delete that? Simply, what we can do is previous dot next means, see here, this is my previous node. This is my, sorry, this is my slow. What the slow dot next is pointing, I should point to that my previous dot next, so that here the link is lost, so this node will be deleted. Means what is the step here? Previous dot next is equal to slow dot next. Where the slow dot next is pointing, my previous point next should point out to that. So is there is no link here, the link is lost, so there is no node here. That's about the deleting node at middle. Okay, now let's go to how to delete the last node. Now, okay, here also the same story. So if there is no node to delete. If I have only one node, then I should delete that node and I should point my head to null. And if there are some nodes which are greater than one, what I want to do is I let me take like temp or something. Now I should traverse this temp up to my temp dot next should not equal to null. See here, temp is pointing to head now. Temp dot next is not pointing to null. No? Again, my temp will go here. Okay. Again, I will check. My temp dot next is not equal to null. Again, my temp will traverse. Again, my temp dot next is not equal to null. Again, I will go to here. But here, my temp dot next is pointing to null. I will stop here and I will make, what is the third condition? Temp dot next will equal to null. Means temp here, no, temp dot next will be null here. Means there is no node. That's it. So we are just making this temp dot next is equal to null. That's it. Null means there is no other node. That's it about this deletion of node at last in the linked list. So that's it about this deleting node at first, at middle, and at last. So let's start coding now. Okay, let's start coding now. Here are the three methods to be filled: delete at first, delete at middle, and delete at end. So what are the two conditions that are common for three methods? That are, if my head is equal to null, then I want to print like system dot out dot println no delete. Okay, so and what is the next condition? Else if my head dot next equal to null, means there is only one node, so that node should be deleted. How can I write? My head is simply pointing to null. This is the two things I have to fill, else condition. So this is common for every method. No, let me copy this and let me paste. Okay, let me paste here also. Now, okay. How to delete the first node? Simply only one thing here. Head will point to head dot next. My head will pointing to head dot next. That's it. I already explained at the beginning of this video. Okay. And how to delete the node at middle? So first of all, I have to take a node. Let me take node slow is equal to head. Okay. And node fast is equal to head dot next. Okay. And I'm also maintaining some other node, that is node previous, means previous to slow, is equal to null, initially null. Now what I'm doing is while, okay, while my fast not equal to null and fast dot next also should be not equal to null, then what I'm doing, I'm simply taking my fast to fast dot next, two steps behind. Okay, not behind, in front. And again, slow is moving to one step, slow dot next. Sorry, next. And where is my previous? My previous should be slow now. My previous should be slow, and my slow is moving to slow dot next. So that's it. Now, after this while loop, what I should do? Simply my previous dot next is equal to my slow dot next. That's it. That's it about deleting node at middle. Now, what is this delete at end? This is also very easy now. So, have to maintain some temporary node here. Let's take node temp is equal to pointing to head. Now I want to say while my temp dot next dot next should not equal to none. Then I will take my temp to one step of the temp dot next. At last, what I'm doing now, my temp dot next is pointing to none. That's it. That's it about this delete at end, delete at middle, and delete at first. Let me save this and let me take you to my main.java. I already wrote some functions here. I already explained how to insert at end, insert at middle, and insert at first. Now in this video, I already explained insert, delete middle, delete and delete first. Okay, first of all, let me trace this. What will be the output? Okay. First of all, deleted middle. Deleted middle means I will get output like no node to delete. Okay, no node to delete because there is no node to delete. And inserted m means I will get like this. Okay, 2. Here it will be null. Now deleted 10. Deleted 10 means again this 2 will be deleted and again my head is pointing to null. And again inserted and 5. Now new node is created and this is null. And inserted middle means here only my 10 will be inserted. It is null now. Inserted first, again here 33 will be inserted. Inserted first, again 34 is inserted. Inserted end, again 7 will be inserted. This is pointing to null. Inserted end 8 again. So it will be inserted. This is pointing to null. Delete middle. What is the middle one here? 10. So 10 will be deleted. Okay. So this is for 1. Delete 10. This 8 will be deleted. This is pointing to none. Deleted first. This 34 will be deleted. This is pointing to head. And at last I will have only 33, 5 and 7. So let's see what will be the output. My output will be no node to delete and at last 33, 5, 7. Okay, let me run it now. Okay, what will be my output? I will write here 33, 5, 7, no, and no node to delete. At last, no node to delete. This is our expected output, but what is the actual output? We can do it now. Okay, let me run this. Okay, Java space main.java. No errors. Java space main. Yeah, I got no node to delete and 33, 5, 7, 8. So why 8 is also deleted? Is it tracing nicely or not? Let me again trace it. Okay, I think we forget this line. Okay, list dot insert at end 6. We forget this line. That is the reason if I call delete at end, so my 6 will be deleted, my 8 will be there. I think we have forgotten this 12th line. Again, we can trace it out. Okay, no problem. First of all, delete at middle means no node to delete. Insert at end. Okay, insert at end means you will be inserted and again delete at end. Okay, this will be deleted, and again, so I will take it. Again, insert at end, my 5 will be inserted and it is pointing to null. And insert at middle means your 10 will be inserted and it will pointing to null. Okay, and again, insert at first means at first 33 will be inserted, and insert at first 34 will be inserted, and insert at end 7 will be inserted and it will pointing to null, and insert at 8, again 8 will be 8 will be inserted and it will pointing to null, and again insert at end 6, so 6 will be inserted, it will pointing to null, and delete middle. What is the middle one? This 10, no? I will delete this. Okay, insert at end, this will be deleted, and insert delete at first, so this will be deleted. So my output will be 33,578. It will also get printed. I think we forget this line, insert at end 6. That is the reason we got up to 33,577. Okay, now let me check. Where is this all the things? Let me check again. Okay, Java space main dot Java. Sorry, Java space main dot Java. No? Okay, space main dot Java. Okay, no errors. Java main. That's it. No note to delete. And 33,578. That's what we got here. Okay. So that's it about this deleting node at first, middle, and at end. Okay. Thank you, friends. Thank you for watching this video. The coming up video is insertion and deletion of a node at a particular index. So, for example, a given index is 3. So, you have to insert a node at that particular index or delete that node at particular index. So, we have not discussed this. We just discussed how to insert and delete node at first, middle, and at last. So, we did not discussed at a particular index. So, this topic is very easy. So this is the coming up topic, and subscribe to my channel Tweetcoder to get notified for the further videos. Thank you. Thank you for watching.